And the unit of the work is joule. We have to write down over here. The same value I will be writing down over here, so that will be 1.4 multiplied by 10 raised to 9 joule. So this value will be this. Now the second sub question here, you can see the mass of the train is 450,000 kg, that is 4.5 into 10 raised to 5 kg, and calculate the maximum possible speed of the train at the end of the first 4 km of the journey. So we are asked to find out the maximum speed. For that we are using the formula for the kinetic energy, and since the work done and the kinetic energy are interconvertible, and we can equate the kinetic energy with the work done. So work done we have already calculated, that is 4.5 into 10 raised to 9 joule. That should be equal to the kinetic energy. The kinetic energy is half into mass into v square, and we can equate them to calculate the value of the maximum speed. So we can equate them to calculate the value of the maximum speed here. So I will write down the work done will be equal to half into m into v square, and that is nothing but this. So the v square, we can write down the v square will be equal to if you make the v square as a subject here, and then you can find out it will be the work done. It will be nothing but the work done, this multiplied by 2 divided by the mass. So this is the, if you make the v square as a subject, you will get 2 multiplied by the work done divided by the mass of the train. So here you can write down the work done is already, we know the work done value is nothing but 1.4 multiplied by 10 raised to 9 here. This is the value of the work done that we already calculated, multiplied by 2 divided by the mass, that is 4.5, and write down 4.5 into 10 raised to 5 here. So this value is nothing but this, and if you calculate this entire value, then you will get all this thing. So if you calculate this value will be coming close to the around 6400. So that value is nothing but v square. So if you make the square root of this, so if you make the square root of this is nothing but v square. So if you make the square root of this both side, v square will be v, and 6400 will be 80. So 80 meter by second. Meter by second is the unit for velocity, so maximum speed will be 80 meter by second. So we'll write down over here again. So 80 meter by second will be the maximum speed. So we have just equated work done is equal to kinetic energy, then v square as a subject, and then we can calculate this 6400 will be v square. So taking the square root on both the sides, will get the value of v will be 80 meter by second. Now in practice, the third sub question, the speed of the train is much less than the value calculated in this 2. Okay, so here 80 meter by second, it is not exactly this, but such is one reason why this is the case. And we know that as I already told you, the some energy is always dissipated in heat energy or any other energy, and work is always done by the friction as well. And the speed, you can say, due to the, and write down, due to the work done against the friction, work done against the friction, the speed is actually less because there is a friction, and work is done by the friction as well, which reduces the speed. Or you can also write down some energy is converted into the thermal energy as well. That is also okay with this question. The last one, the after traveling 4 km, the train reaches the maximum speed. Here it continues at this constant speed on the next section of the track, where the track follows a curved path. So here after that, the track follows the curved path here, which is a part of the circle here, and state the direction of the resultant force on the train as it following the curved path. So we know that whenever we have the curved kind of path, and which is a part of the any circle, the force acting is always toward the the center. Force acting on the object is always toward the center of the circle of that curved path. That is nothing but called as the centripetal force. So we can write down the direction of the force, direction of the resultant force is always, you can say, the perpendicular to the curved path, or you can say towards the center of the circle. We know that that is nothing but the centripetal force. Any object is moving in a circular path, we know this force acting is the centripetal force always toward the center of the circle. So let's go to the next question. Now the question number 3 here, the boxes on the left contains the names of the some sources of energy. So here you can see some sources of energy are here. The boxes on the right contains some properties of the sources of energy. So here are some properties given. Draw two straight lines from each box on the left to the boxes on the right, which describe the source of energy. Okay, so we have to just draw the line here. Here the solar energy is here, the natural gas is there, and you can see here the properties are given, like renewable, not non-renewable, polluting, and the non-polluting. So we know the solar energy, we had seen the solar energy is a renewable kind of energy, and the solar energy is nothing but, can say, it is a renewable energy. First of all, that is the one thing we had seen before, and the second thing we had seen, it is basically the polluting, because it uh, basically contains toxic materials. That is nothing but the polluting part of the solar energy. So natural gas, we can see natural gas is a non-renewable kind of energy source, and the natural gas is what kind of thing is this? It is again the polluting thing. Okay, both are polluting thing. So but one of them is a renewable, one of them is a not renewable. So that this is the way we can do for the first question A here. Now this B question is a coal fired power station of polluting, and state the advantage of using the coal as the source of the energy. Though it is polluting, there are some advantages and disadvantages we have seen. What are the advantages? The advantages is that it is relatively, you can say, it is relatively cheap, and another one important thing, you can also write down one more point here, it's widely available. It's very easy to have the availability of such kind of coal fire station, and that's why it is reliable. In that sense, availability means what? It is a reliable kind of source, and it's relatively cheap. It's not that cheap, but only relative comparison it is a cheap that way. The C part here, the coal fire power station generates electricity at the night when it is not needed. Some of this energy is stored by pumping water to the amount to a mountain lake here. Then when there is a high demand of the electricity, the water is allowed to flow back through the turbines to generate the electricity. We had seen all the flow, like how the water is stored, is coming down, converts that energy, potential energy, into the kinetic energy, then that runs the turbine, and turbine runs a generator, and that generate the electricity, etc. On one occasion, you can see this much, 2.05 into 10 to 8 kg of water is pumped up through a vertical height of 500 meter. Here calculate weight of the water. So weight of the water is a very simple thing. Weight of the water, we can directly find out. Weight is nothing but mass into the gravity, and we know that mass of the water is already given, that is 2.05 multiplied by 10 raised to 8. 10 raised to 8 is given already here, so this weight is very simple. Into the gravity, we can say it is 10, so we have to just multiply this number with 10 here, then acceleration to gravity, and we are getting the value of 2.05 multiplied by just 1 power more, so 10 raised to 9. This is the way we are going to have this, and the Newton is the nothing but the unit of that weight, so it is nothing but the type of the power, nothing else. So here I will write down here that thing again, 2.05 multiplied by 10 raised to 9, so that is nothing but Newton, and this is the way we can answer the A part. Now the next question is this: the calculate the gravitational potential energy needed gained by the water. So we know the gravitational potential in the formula is already given here. mgh here, the same mass is pumped through the vertical height of 500 meters. So height is also given. We can write down the gravitational potential.